Hi, my name is Bryson Wingate, and this is Pocket Clash, my project for Vertical Slice Remake. Pocket Clash recreates the core experience of Pokemon Battle through a complete two versus two encounter rather than recreating the entire RPG. My goal was to build a polished vertical slice focused entirely on the battle system. Now, as you can see, the game starts by allowing the player to choose two Pokemon from the available roster. Now, each Pokemon displays its type and statistics so that the player can build a team before entering the battle. Now, one change I made allowing was allowing the opponent to choose from the full roster instead of just simply receiving the leftovers the player didn't select, and that makes the team feel independently assembled. So I'm going to choose Cinderace and Volturi. Now, each active Pokemon displays its name, type, and let me place it right here. Name, type, HP, and current health bar. The small team indicators show below which Pokemon remains available, and when a Pokemon faints, its square becomes gray so the player can quickly understand the state of both teams. It has 4 available moves. Each move displays its type and remaining PP. Let me choose the damaging move right here. And speed determines which Pokemon attacks first, and damage is calculated using the attacker's attack stat and the defender's defense stat, and the move's power and any type of effectiveness multiplayer. And now I'm going to try a status move. And as you can see, not every status move deals direct damage. Some moves instead increase attack, defense, or speed, and these changes remain active for the rest of the battle, creating additional strategy simply choosing the strongest attack. And when a Pokemon reaches zero HP, it faints, and the next available Pokemon automatically enters the battle, as I'm about to show. And as you can see, his Cinderace fainted. So let me play it again. So I'm gonna stop it there. Now the first half of my GDD analyzes the original Pokemon battle system from a architectural perspective rather than simply describing the gameplay. Now at the center is the battle manager. The battle manager controls the overall flow of combat. It owns both teams, keeps track of the active Pokemon, coordinates turn resolution, and determines when the battle ends. Now, the Pokemon system represents each combatant. Every Pokemon stores its name, type, maximum HP, attack, defense, speed, and available moves, and whether it has faded. And lastly, the move system defines every action available during battle and therefore stores its name, type, power, remaining PP, and any additional effect that the move applies. Now, the damage calculation system combines the attacker's attack, the defender's defense, move power, and type effectiveness to determine the final damage. And the type effectiveness system compares move types against Pokemon types and determines whether the attacks are super effective, neutral, or not very effective. Now, for the turn order system, it compares speed every turn so that the faster Pokemon attacks first, and the AI system chooses one legal move for the opponent each turn. And finally, the user interface displays the current battle state, accepts the player's input, and refreshes after each completed turn, while the victory manager determines when either trainer has lost all usable Pokemon. Now for part two, this is defining what I included in my vertical slice. Now this slice includes team selection, HP tracking, PP tracking, attack and defense speed statistics, elemental type interactions, turn-based combat, automatic replacement after fainting, battle messages, and victory and defeat screens. Now, I intentionally left out exploration, catching Pokemon, evolution, weather, multiplayer, and other RPG systems because the purpose of the project was to recreate the battle experience rather than the entire Pokemon game. Now, I did go through one change of my original GDD that I added simplified status moves because and instead of course, instead of implementing poison, paralysis, or sleep. These moves modify attack, defense, or speed. And I made this change because the battles with only damaging moves became a little bit too straightforward, and at least these stat changing moves added a little bit more strategic decision making while still keeping the project within the intended scope. Now, overall, my success criteria were that players immediately recognize the game as Pokemon, understand that the speed controls turn order, manage the remaining PvP for the moves, consider type matchups, and experience a complete battle from team selection to their victory or defeat. Now, onto the system architecture. Now let's start with the index HTML. The HTML is organized around three major sections, essentially: the team selection screen, the battle interface, and the battle results screen. Now, rather than loading different pages, JavaScript simply hides and reveals these sections using the hidden class. And the HTML also contains empty containers like the creature selection grid, move grid, player team slots, opponent team slots, and the resulting team. And the render functions populate these containers as the battle state changes, essentially. So the player and opponent status cards use matching IDs, allowing the rendering code to update either side using an is player condition. Now on to style. Now the style begins with a root variable block. This stores all type colors, HP colors, and shadow values, making the game easy to reskin by changing the variables here instead of individual selectors. Now the battle background is created entirely with CS gradients using the sky, hills, and ground layers rather than image assets. And attack movement, damage flashes, and faint animations are all CSS keyframe animations. And the JavaScript simply adds the animation classes when those effects should occur. And the HP bar colors also come directly from CSS. And with the get HP color class function returning either high, medium, or low health, and the CSS determines the final appearance with red, yellow, or green. Now, for the most important, nope, that's not the most important one is script.js. So our move and Pokemon classes serve as the primary data models. Pokemon stores like combat statistics, HP moves, and the attack, defense, and speed modifiers used by status moves. Both classes also contain the clone functions rather than modifying clone the original database. Every battle uses clone Pokemon and clone moves, allowing HP, PP, and stat changes to reset correctly after each match. Now, as for the Pokemon database, access the single source of truth for every Pokemon and move definition. Combat calculations are separated into three major functions, such as get type effectiveness determines the damage multiplier, while calculate damage computes the final damage, and the apply move effect handles stat changing moves. Now, separating these functions made the combat logic easier to maintain. Controls the entire game state machine, and because the battle progresses through team selection, waiting for player input, opponent move selection, turn resolution, and etc. And the execute move function coordinates an individual turn. It verifies the PvP amount, play animations, and applies either the damage or the stat changes, and simply renders the new state and waits for animations to finish before continuing. And finally, our render functions. It's a lot of code here. Render functions act as the bridge between the game state and the interface, and the battle manager updates the game data first, and then the render functions repaint the HTML to match the new state. Now, as for question one, I'm going to to adding a second player to your game right now. Walk me through all system changes and the order I would change them and explain dependencies. I would start immediately by changing the data model. So right now the game assumes one human player and one AI opponent. Now I would create a trainer class that owns a team, active Pokemon, selected move, and player identifier, and that change comes first because every system depends on how the trainers are represented. Next, I would have to modify team selection so that both their players could build on their own teams, and after that, I would have to remove the opponent AI and replace it with a second player input state. And the battle manager would wait for both players to select moves before resolving the turn. And then next, I would have to update the interface because on one computer I could hide the first player's move selection while the other player chooses. But if multiplayer were online, this instead the battle state will have to move into a server so that neither player can control the entire game state. Now, thankfully, for most of the combat systems, they would require very little change because they already operate using attacker and defender objects. So essentially, the dependency order would be the trainer module, team selection, player input, battle manager states, interface, and then player synchronization. Now, for question 2, the GDD says the slice represents the full game. Convince me that a player who only plays your slice understands what makes Pokemon compelling. Now, although my slice excludes stuff like exploration, progression, and story, it also it does recreate the complete battle experience. The player still has to manage the PP type matchup, speed, HP, and team composition, and choosing the strongest move. What is not always the correct decision, essentially, and a player may instead choose a move that increases speed to attack first on future items or lowers the opponent's defense while using a stronger attack later. And when the first Pokemon faints, the second Pokemon creates a completely random, completely new matchup rather than immediately ending the battle. And those decisions, like resource management, protection, type advantages, and turn order, are what make Pokemon battles engaging, and they're all represented in this slice. Now, worst architectural decision in my code base, that would have to be the battle manager, easily. Let me scroll all the way up. Scroll all the way up. Battle manager, battle manager, battle manager. It is in there somewhere. Now, the biggest architectural weakness is mixing the battle manager class with a global battle state. Because the battle manager controls the battle, but variables like player team, opponent, and active player Pokemon and active opponent Pokemon still exist globally. That makes ownership less clear than it should be. Now, if I had restarted this, I would move all the battle state into trainer objects owned directly by the battle manager, and then the render functions would receive trainer objects instead of reading global variables. The cost would be a fairly large refactor because almost every rendering function and battle transition would need updating, and so, but yeah, but the current design works, but it makes extending the game more difficult, especially if multiplayer were added. Now, for question 4, the original game has been played by millions of people. Your slice has only been played by a few. What do you not know, and how would you find out? I don't know whether the battle remains strategically interesting after the player discovered the strongest combinations, and I also don't know that whether players naturally understand the stat changing moves or simply choose whichever move has the highest damage. The random AI might also be either too weak or unintentionally frustrating. And now to answer those questions, the obvious answer would be performing larger playtests and record statistics like battle length, move usage, Pokemon selection frequency, win rates, and how often moves actually affect the battle outcomes. And I would also compare experienced Pokemon players with new players to understand whether the strategy is deep enough for veterans while remaining understandable for beginners. Now, overall, for the postmortem, I think the strongest part of the project was separating the combat calculations from the interface. Functions like calculate damage and apply move effect remain independent from rendering code, making the combat system easier to modify. The clone system also worked well because every battle essentially started with fresh Pokemon instead of modifying the database. But the biggest challenge was coordinating all the battle states. And damage calculations themselves were finished relatively early, but making team selection, switching animations, and battle messages, etc., require much more state management than I originally expected. And like I said, if I started all over, I would build a trainer class first and move all the battle state inside the battle manager instead of relying on global variables. I also planned that the stat changing move system from the beginning rather than adding it later. Another thing I learned was that my original architecture diagram was more class oriented rather than my final implementation. Several planned systems like damage calculator and type chart ultimately became standalone functions instead of separate classes. And that taught me that good architecture, of course, comes from separating responsibilities, not necessarily creating more objects. Overall, I feel I stayed very close to my original scope while improving the battle system with stat changing moves, better visual feedback, and animations. And I believe the finished project successfully captures the core experience of Pokemon battles. Thank you.